All right, guys, I'm going to do this example, just jumping back into the Taylor polynomials and talking about the questions that you may see. So in this one, you're going to have to construct the fourth order polynomial centered at 0 and for the function square root of 1 plus x squared. Okay, so when you're doing this, a couple things that we want to have is fourth order. Okay, means the fourth degree. So you want to get this to have an x to the fourth in your polynomial. All right, so that's where we want to end. We have a degree of 4. So fourth order really just means degree of 4. You might have heard that before in algebra 2. Now, I'm going to go back to this formula that we're going to use. So again, what we're going to try to do is, well, the first thing is easy. We're plugging in f of 0, but then we have to do that for f prime of 0 and so on. And we're going up to x to the fourth. So we have to do our first 4 derivatives. And then we could use this formula that was given to us. So let's start. So I want to first take my first derivatives. So remember, you could rewrite it this way. So our first derivative is going to be 1/2 1 plus x squared, right, to the negative 1/2 times the 2x. Remember, chain rule, right? So we could simplify that down where the 2's cancel and you get x over square root of 1 plus x squared, like that. Okay, so we got to continue to do derivatives here, and then at the end I'll plug in 0 for each of them. So depending on what rule you want to use, okay, you could use product rule, you could use quotient rule. It doesn't really matter in this situation. I'm going to use quotient, right, just because I have it set up that way. And here I'm going to get derivative of x is 1 plus x squared stays, minus x is going to stay, and then I'm going to have the 1/2 1 plus x squared to the negative 1/2 times 2x again, right? And then we're dividing everything by that square root of 1 plus x squared, the whole thing squared. So if we simplify this down, right, we would have so here the 2's will cancel, and then you get x times 1 plus x squared to the negative 1/2. And that winds up being x squared, right, 2 x's, and all divided 1 plus x squared when you square it out like that. Now this is a little bit tricky because you kind of want to simplify this down before you do anything else here, okay? This is just good practice with our derivatives. So one thing here is this is a square root, right? So if we break it up and we have, right, the square root 1 plus x squared, and I'm just going to write this into 2 fractions, right? You have that minus x squared is going to be in the numerator, and then you have still that 1 plus x squared, but then times that square root of 1 plus x squared. The reason why I'm doing that is just to make it a little bit easier, okay? So here, if I multiply both, common denominator, they both have the 1 plus x squared, but I need to get that root out of there. So let's multiply this one by the root. You get 1 plus x squared minus x squared all over 1 plus x squared and square root of 1 plus x squared, okay, which winds up coming to 1 over, and I'm going to rewrite this as 1 plus x squared to the 3/2, just to make it a little bit easier for us when we get to our third derivative, fourth derivative, okay? So for the third derivative, okay, we are going to rewrite that to make it easier and use chain rule. Just give me 1 second. All right, so we're going to use okay, so this winds up being a negative 3x all over. We have square root of 1 plus x squared to the 5th power now, right? Yeah. And the 4th, I'm going to just give you guys, but again, you could do quotient rule, you could do the other rule that you need. If you want to do product rule, you could do product rule from here, but I'm going to wind up giving you this here, which is going to wind up being 3 times 4x squared minus 1 over x squared plus 1 to the 7/2. All right, so we have our derivatives, okay? And again, sometimes this takes quite a bit of work to do. So let me just jot them down and show you how we're going to use them to get this polynomial. All right, so the first one, okay, we have that. All right, that's our function, okay? Then it came out to x square root of 1 plus x squared. Our second derivative was 1 over 1 plus x squared to the 3/2. Our third derivative was negative 3x, and then I'm going to write it this way, to the 5/2. And our fourth derivative is going to be 3 times 4x squared minus 1, and then x squared plus 1 to the 7/2. Okay, so we have all of that. Let me just double check that my work is right. First is okay. Second is okay. Third is okay. And we're good. All right, once you have that, now we're plugging in 0 for all of these. F of 0 in this case would just be 1. F prime of 0 is going to be 0, right? 0 over 1. F double prime of 0 is going to be 1 again. F triple prime of 0 is going to be 0. And F to the F fourth derivative at 0 looks like we're going to get a negative 3. Okay, now using the formula for Taylor polynomial that I gave you guys, okay, we're just really setting up the polynomial using this notation. So I know this might be a little confusing on this notation, but let me go through the step by step, okay? So the first one, so here's our polynomial, and usually you put a little 4 with the fourth, so p sub 4 means your 4th degree polynomial for this square root of 1 plus x squared is going to be, the first term is just the first term, 1. You don't have to put anything with it. It's really like x to the 0 plus, now I'm taking my derivative, right? So first derivative, right, at 0 is 0x, okay? The next one, right, taking that coefficient for my second derivative, so plus 1x squared over 2 factorial based on the formula that we have, okay? Our third one, okay, right here, the third one is going to be plus 0x cubed over 3 factorial, and then our fourth is going to be minus 3x to the 4th over 4 factorial. Notice how Even there is, if you want to put this, a 1 factorial there as well, and you have your initial 0.01 from the original function. And now we just simplify this down. So it's going to be 1, 0 times anything is 0. This is just going to be x squared over 2. 2 factorial is 2. 0 times anything is 0. Minus 3x to the 4th over, this will wind up being 24. So I'm going to even simplify further, right? And get 1 plus 1/2 x squared minus 1/8 x to the 4th. And this is the 4th order polynomial that we're looking for.